humanity realized something profound. This wasn't just another rock from space. It was a messenger. One that might hold the story of worlds we've never seen, and a chemistry that doesn't belong to our sun, our planets, or maybe even our kind of life. Once 3IATLAS was confirmed as interstellar, the world's telescopes turned toward it in unison. For the first time in human history, Earth and Mars were both watching the same cosmic visitor from two different worlds. NASA coordinated with observatories across Chile, Hawaii, Spain, and even the James Webb Space Telescope, aligning their instruments to capture every glimmer of data as the object streaked through the inner solar system. From Mars, Perseverance continued to monitor the skies, while orbiters like MAVEN and the Mars Reconnaissance Orbiter tried to detect faint thermal traces in the upper atmosphere. As the data poured in, a strange rhythm began to emerge. 3IATLAS wasn't shining steadily. It was flickering. Every 8.3 hours, its brightness would dip and rise again, like a silent cosmic clock ticking in deep space. That steady rhythm wasn't random. It hinted at rotation, the slow tumbling of a solid body as it spun through the void. The pattern reminded scientists of the first interstellar object ever detected, Oumuamua, which also flashed at regular intervals due to its elongated, cigar-like shape. But in the case of 3IATLAS, the signal was stronger, the variation sharper. The amplitude of the brightness changes suggested something long and narrow, possibly 10 times longer than it was wide, a geometry rarely seen in natural space debris. Even stranger, the object's reflective pattern didn't behave like a uniform rock or comet. It reflected light more intensely on one side, suggesting either a metallic surface or one covered in reflective compounds. If it was a natural object, it was one sculpted by forces unfamiliar to our solar system. If you love exploring the cosmos, subscribe now and like this video for more incredible space discoveries. Ground-based telescopes confirmed the same rotational signature. As the object passed within Mars's orbital distance, researchers noted subtle deviations in its brightness curve, tiny inconsistencies that hinted at irregular geometry, perhaps facets or panels reflecting sunlight at different angles. The data didn't scream artificial, but it whispered it, just enough to make even the most skeptical scientists raise an eyebrow. For days, Earth and Mars shared a cosmic connection. Observatories 225 million kilometers apart were studying the same faint streak of light, watching as it spun like a slow, drifting relic of the galaxy's distant past. Mars saw it first, Earth confirmed it next, and humanity as a whole realized what was happening. For the first time, two worlds were working together as a dual-planet observatory, united by curiosity. The brightness fluctuations continued until the object began fading from view. The last confirmed readings captured a final rotation cycle before the data signal vanished into solar glare. It was as if 3IATLAS had turned its last face toward the sun, glinted one final time, and slipped silently into the dark. But those rhythmic flashes, those 8.3-hour pulses, left behind a haunting question. Was it simply a tumbling shard of cosmic rock? Or was it something built to spin, deliberately balanced, carrying its own story through the endless gulf between stars? Whatever it was, Mars and Earth had witnessed its dance together, and in that fleeting moment, humanity had looked across two worlds and seen the same mystery turning in the light of another sun. Then came the moment that changed everything. A single frame, a single flash, and a mystery that no one could fully explain. In one of Perseverance's follow-up sky captures, something extraordinary happened. For less than a second, the camera recorded a sudden bright pulse, a burst of light so sharp it oversaturated the sensor. It wasn't a cosmic ray hit or a software glitch. This was real light, bouncing from something above Mars. The flare was brief, but unmistakable, a clean spike in luminosity perfectly aligned with the predicted path of 3IATLAS. At first, scientists thought it might be sunlight glinting off a patch of reflective ice. But that theory started to crumble as soon as they ran the numbers. At the object's distance, a flare of that intensity would require a reflection far stronger than ice or rock could produce. The brightness was metallic, a crisp, mirror-like reflection, the kind you'd expect from a polished or flat surface. It lasted less than a heartbeat, but the rover's instruments captured its spectral profile, a near-perfect reflection of the sun's color signature, almost as if a small portion of the object had acted like a mirror turning toward Mars for just an instant. That one frame sparked a global frenzy. The scientific forums exploded with discussions, data analysis, and cautious disbelief. NASA's official stance was restrained. They called it a transient optical event consistent with natural reflection. But behind the scenes, engineers and data specialists were baffled. There was no indication of interference, no power spike in the rover's systems, no evidence that the flash came from anything within the instrument itself. It had come from the sky. The timing of the pulse was almost too perfect. It occurred exactly at the midpoint of 3IATLAS's visible pass over Mars, right when its rotational axis would have been facing the planet. Coincidence? Probably. But to many, it was hard not to wonder if that flare was something more, a controlled or reflective signal, an intentional glint designed to catch attention. Some compared it to the way satellites on Earth reflect sunlight in sharp bursts known as iridium flares. Could this have been the same phenomenon, but from an interstellar object? Others offered a more grounded view. Maybe the flare was just sunlight hitting a patch of exposed metal or crystalline ice as the object spun. After all, space is full of surprises, angular fragments, ice-coated stones, and reflective minerals that can mimic artificial light. But even those explanations didn't dampen the curiosity. The fact remained, the flash was real, powerful, and perfectly timed. For those watching the data unfold, that single flare became something symbolic. It was as though Mars had received a glimmer from beyond, a silent wink from the dark between stars. Whether it was coincidence, physics, or something far stranger, no one could deny how hauntingly precise it felt. And as 3IATLAS continued on its path, fading slowly into the blackness, one question lingered across every lab, observatory, and late-night discussion thread. What if that flash wasn't an accident? What if, just for a moment, it was looking back? When the images and data from 3IATLAS finally reached the public, something shifted, not just in science, but in how we see ourselves. For decades, Mars had been the observed, the target of telescopes, landers, and dreams. Humanity looked at it as the next step in our story, a world to conquer, explore, and study. But now, for the first time in history, the roles were reversed. Mars had become the observer, a world we sent machines to, now watching the universe on our behalf. That realization sent ripples through every field of science. Philosophers, astronomers, and ordinary people alike paused to grasp what it meant. A robot we built, on a planet 225 million kilometers away, had looked up and captured the passage of an object born around another star. That single moment stitched together three realms, Earth, Mars, and the vast interstellar unknown, into one continuous thread of awareness. For the first time, two planets in our solar system were active participants in observing a traveler from another world. Humanity wasn't just earthbound anymore. Our eyes were now in multiple places across the solar system, watching the galaxy unfold. It forced scientists to think differently about what we are capable of. Mars had become a mirror of human curiosity, a red, silent witness to the cosmos, watching the same mysteries we do. For many, it felt poetic. The planet that once represented exploration was now helping us explore the stars themselves. We weren't just sending data back and forth anymore. We were expanding our perspective, literally creating a solar system-sized observatory. But beyond the science, there was something deeply emotional about it. To some, the sight of 3IATLAS streaking across the Martian sky was humbling. A reminder of how small and temporary we are compared to the grand machinery of the universe. That faint streak wasn't just a scientific object. It was a messenger from the unknown, carrying secrets from a place so distant that its home star might not even exist anymore. Others saw it differently. They saw hope, proof that our technology, our ambition, and our curiosity had reached a point where we could witness interstellar phenomena not just from Earth, but from multiple worlds. The fact that we were able to coordinate observations from two planets spoke volumes about how far humanity had come and how much further we could go. Even the scientists, who spent their careers working with hard data and careful language, couldn't help but feel awe. One NASA researcher wrote in a post-analysis report, "For a moment, Mars looked up and saw the galaxy." That single sentence captured it perfectly, because in the end, this wasn't just about discovering an interstellar object. It was about perspective, about realizing that we, a young species on a small blue planet, have already extended our reach to another world. And from there, we're watching visitors from the stars. For the first time, Mars had eyes. And through them, so did we. As observations continued, astronomers began piecing together the full story of 3IATLAS's journey. With data streaming in from both Mars and Earth, scientists could perform parallax measurements, triangulating the object's exact position with unprecedented accuracy. This wasn't just a fuzzy streak in the sky anymore. It was a pinpoint moving across millions of kilometers, and every frame told a story of motion, age, and origin. By comparing the rover's data with Earth-based telescopes, researchers refined the object's trajectory to a degree never before achieved for an interstellar visitor. They could calculate its speed, rotation, and path through space, and the results were staggering. 3IATLAS was traveling at nearly 60 kilometers per second, a velocity so high that it would escape the sun's gravity forever. Its course wasn't random. It was precise, hyperbolic, and carrying the signature of a journey through the galaxy that likely spanned millions of years. The refined trajectory also allowed scientists to trace the object backward, past the solar system and deep into the Milky Way. The calculations pointed to a faint, ancient stellar association roughly 300 light-years away. This region, known for its debris belts and older stars, could very well have been 3IATLAS's birthplace. Imagine that, a tiny fragment born around a distant star, ejected by gravitational chaos or planetary collisions, traveling across the void for millions of years, only to intersect our solar system perfectly. The thought was humbling. 3IATLAS had seen more stars, more radiation, and more galactic environments than humanity ever could. It had witnessed the rise and fall of civilizations, the shifting of planetary systems, and the silent dance of stars long gone. And now, at this fleeting moment, it had been observed by humans from two worlds, catching a glimpse of its endless journey. The precision of these measurements also opened new scientific doors. Knowing its exact origin allowed researchers to speculate about its composition, age, and the conditions of its home system. Could it carry exotic minerals, rare isotopes, or even chemical signatures of life from another star? Each calculation added weight to the object's mystery. Each data point a bridge across hundreds of light years, connecting Earth, Mars, and a distant stellar nursery. In essence, 3IATLAS was no longer just an object. It was a messenger, a time capsule from a far-off star system, traveling silently through the galaxy, now recorded by humanity's instruments. The faint streak that Perseverance captured wasn't just a streak of light. It was a cosmic thread tying our solar system to a distant neighborhood of stars, reminding us of how vast and interconnected the universe truly is, and how small, yet capable, we have become as observers. Before you go, don't miss what comes next. Click on the video in the end screen to continue exploring the mysteries of the universe. See more mind-blowing interstellar discoveries. Trust me, you'll want to watch every second. The journey is only getting wilder.